Hey, this is Neil here again from Sample Physics here again. And today what we're going to be looking at is another question here that basically shows you two objects on a pulley system with a string that basically you can't stretch. And what we call this is that we've actually got a string that you cannot stretch, and the actual wording behind it is called inextensible. Inextensible. Okay, and what that means is you can't stretch the string. And we've got two masses obviously attached to both sides as well. We're also going to assume that the friction within the actual pulley system is actually going to be equal to 0 newtons as well. So there's no friction involved in the actual pulley system as well. But we do know is that when you have two objects, for example, one is 3 kg, one is 2 kg, naturally what's going to happen is that the object is actually going to move in one direction. Okay, and we can see from this that the mass here is larger compared to here. But before we actually sort of start obviously showing what actually happens directly, we can now look at in more detail that there's a force acting downwards, which is actually going to be represented by the mass times by gravity. And what we're also going to have is there's also going to be another force acting down here. That's also going to be 2 times by gravity. Now, to be honest, strictly speaking, what you should really do is that you should actually make this force larger, because it's 3 times gravity compared to 2 times gravity, where this is a vector quantity, so the actual arrows will be longer as well. Okay, so longer the force, larger the force. Okay, that's what we're basically showing here right now, and that's what we should do really. We should actually have the force longer here. Now, at the same time, because we got the force actually pulling down this object, there's also going to be another force that is actually going to be acting in the opposite direction. And that's really going to be largely due to the fact that Newton's third law of motion, every object has an equal but opposite reaction. So we're going to call this tension. So that's going to be a T value here. At the same time, we're also going to have another value here, because obviously this is moving, this is basically one complete rope, or basically string. The tension here is also going to be acting in this direction here as well. That's also going to be called tension as well. So the tension is going to be the same along the length of the whole rope. Now that we basically established the forces acting on the object, we can see from here that because it's a larger mass, the object is going to be moving in this direction. And as a result, when the object does start moving in this direction, downward direction, especially for 3 kg, we are going to have an acceleration acting downwards. The same acceleration will be acting back up this way as well, like so. And we're going to represent this acceleration as A. And we also got now a value T for tension here as well. Now, the question is really focused on working out what that acceleration and tension is. And to do that, we can basically apply, obviously we can look at net forces, and what we can do is we can separate this section of the pulley first of all, so we can focus on what's going on here. And we can see from that the object is moving downwards. So we can say that the force is equal to the mass times acceleration, which really comes from Newton's second law of motion. And we can say that the force, net force, the resultant force is going to be 3g minus the tension is equal to the mass. Now be careful that the mass is actually equal to 3 kg. So you times that by 3. Times by the acceleration, that we still don't know what actually it is. So that's your formula now for the first section here. So you got 3g minus t equals 3a. Now when you now look at this section here, we can see that the actual motion of the object is acting upwards. So we can say the resultant force is T. The resultant force is T minus your 2g, which is equal to your mass again, 2 times by A. Now you've now got two equations side by side that you can actually use to work out what you can work out A and you can work out T. And to do that, we can simply by looking at putting these next to each other, 3g minus t equals to 3a. Now, if you're clever about this, what you can do is you can actually put this underneath, but before you put it underneath, you can actually take the minus 2g and rest it here underneath the g. Yet at the same time, this t value is actually a positive t value, positive tension. So you can put the positive t underneath. Just because you can't see a plus here doesn't mean that it's not plus, it is plus. It's plus t minus 2g. So the plus t actually sits underneath the minus t there. That's equal to your 2a. Now we got this. Now, depending on how good your maths is, you can actually use what we call the elimination method using simultaneous equation method. In simultaneous equations, we use a method called the elimination method, which actually then allows us to calculate g and t. You can actually calculate t and a. To do that, we can add. By adding, we see 3g, add minus 2g, that becomes g. But when you add minus t plus t together, these actually become 0, because you got two values, one's minus, one's positive, but the size of the tension is the same, but it's just that one's minus and one's positive. When you add them together, they will cancel each other out. 3a add 2a will be equal to 5a. So what we're saying is that if you now drop the 5 underneath the g by doing g divided by 5, that's equal to acceleration. And by working out acceleration, where you can assume g is equal to 9.81, which is the g value, divide that by 5, will actually give you a value, which will give you a value, let's have a look, it's going to be 9.81, divide that by 5 equals to, right, we've got a value here 1.962, so I'm going to say 1.9, let's round it off to 1.96 meters per second squared, and that's your value. Unless in the exam you might be given g equal to 10 divided by 5 is 2, but obviously in this case here we use 9.81 to work out the answer for acceleration, which is 1.96 meters per second squared. As soon as you got this value for a, you can now basically work out the t value simply by putting it back into one of these equations here. And we're going to say t minus 2g equals 2 times a. T minus 2g equals 2. Put 1.96 in there, and we can work it out straight away. So t minus, now 2g is 2 times 9.81. So 2 times 9.81, 2 times 9.81 equals to 19.62, and 2 times 1.96 equals 3.92. I apologise, I've just run out of space altogether here, as you can see. So we're what you're going to do is you're going to take the minus 19.62 onto that side. Obviously, when you take a minus over to the other side, it becomes positive. Okay, becomes positive. Therefore, we have your add 19.62 equals, now the answer I've got basically 23.54 newtons. So these are your values that basically fit with the question here. So I'm going to show you a bit more higher up. You can see from here. That that's what you got here. So you can see that by setting out your question like this, so obviously mine's quite cramped at the moment, by setting out the question, the methods that you use are quite important. You can see there's plenty of opportunity here to get method marks. Obviously you can get your answer marks as well. So I would say roughly this could be maybe a 4-mark question possibly, depending on basically how much working out you'll be required to do. This is the kind of question that you can get obviously at A-level physics. Okay, but it's an important question with lots of important concepts in physics that we need to understand. Okay, thanks.